let's dive into a feature that was a real game changer for Java, Lambda expressions. When these showed up in Java 8, it wasn't just about adding some new syntax. Nope, it totally changed how developers write code, slashing through years of old clunky patterns. So let's break down how this one feature brought a much-needed modern touch to Java.
You know, to really get why Lambdas are so great, we have to take a quick look back at the old way of doing things. For a long time, Java programmers had to write a ton of what we call boilerplate code. This was especially true when you were dealing with simple interfaces that only had one method.
Just look at this code snippet right here. It's a classic example. All we're trying to do is sort a list. We have one simple job. Tell the code how to compare two things. But to do that, we have to write all this ceremony, the instantiation, the method signature. You see how the code just keeps growing downwards? It becomes this vertical problem where the one thing you actually care about is buried under 5 lines of syntax.
And that really is the key question, isn't it? It just feels so inefficient. All of that extra code is just scaffolding for the one line that actually does the work. You just knew there had to be a better way.
And there was. Enter the Lambda expression. Java 8 delivered this beautiful, elegant answer to all that boilerplate. The core idea here was pretty revolutionary for Java at the time. What if you could treat a piece of code, a behavior, like any other piece of data? What if you could just pass it directly into a method?
And wow, this slide says it all. On the left, you've got our clunky 5-line vertical problem. And on the right, the exact same logic, but now it's in a single, super readable line. It's a horizontal solution. It's clean, it's to the point, and it focuses only on the action. That right there is the power of a Lambda expression. So how does it actually work? Well, the syntax is amazingly simple. On the left side of this little arrow, you put your parameters, and on the right side, you just write the expression, the actual logic you want to run. The compiler is smart enough to figure out the rest. No need to write out method names or even the return keyword if it's just a single line. It's just the essential stuff. But you know, this slick syntax isn't just magic. It's all made possible by a core Java concept that's actually been around for a long time, the functional interface. This is the secret sauce that makes the whole thing work. So what is a functional interface? It's exactly what it sounds like. It's an interface that has one and only one abstract method. That's the only rule. And because there's only one method to worry about, it represents a single, clear function contract. Your Lambda expression, then, is just a super clean way to provide the implementation for that one method. The compiler sees it, knows what to do, and wires everything up for you. And here's the cool part. If you've been programming in Java for a while, I bet you've used these before, maybe without even realizing it. Things like Runnable for threads or Comparator for sorting, those have always been functional interfaces. Lambdas just gave us a much cleaner way to use them.
Okay, now things get a little more interesting. What happens when a Lambda needs to use a variable from outside its own little world? Well, there's a really important rule you have to know, and it's called variable capture. So here's the rule, and it's a big one. A Lambda can only use a local variable from its surrounding code if that variable is either declared as final or if it's what we call effectively final. And effectively final is just a fancy way of saying you assign a value to it once and then you never ever change it again. So why does this rule even exist? It's all about keeping your code predictable and safe. See, local variables live on something called the stack, which is temporary. A Lambda might live on much longer than the method it was created in. To solve this, the Lambda essentially makes a copy of the local variable's value. And if the original variable could change later, the Lambda's copy would be out of date, leading to bugs. Forcing it to be final guarantees the copy is always correct. Now, instance variables are different. They live on the heap, a more permanent place in memory, so the Lambda can safely access them directly without this restriction.
Okay, so we've covered the what and the how. Let's get to the why. Why was this such a massive deal for Java? Well, the benefits are huge, and they go way beyond just making your code look a little prettier. The advantages here are truly transformative. First and most obviously, Lambdas just obliterate boilerplate, which makes code cleaner and way more readable. Second, they open the door to a more functional style of programming, and that's a big deal. We can now treat behavior like data, passing actions directly into methods, which makes our code way more flexible. On a practical level, you don't even generate those extra class files for every little anonymous class anymore, so your project stays cleaner. But maybe the biggest win of all? Lambdas are the absolute foundation for one of Java's most powerful tools, the Stream API.
So while getting rid of boilerplate was a huge win, the true legacy of Lambda expressions is that they unlocked an entirely new way of thinking about data in Java. They are the engine that powers the Stream API, which completely changed how we process collections of data. And that shift from telling Java how to do something to just declaring what we want, that's the real revolution.